So the question is this cross, and it's a wet refraction basically. There is a cycloplegic that was used, that is cyclopentalate at 2/3 meter. Oh yeah, one advice I would want to give you: if you have a patient in, I mean, it's unlikely these days to have patients during examination, but say they give you a live patient, then don't waste your time too much in getting the glow. So once you get the glow and you are pretty sure it's the glow, just write down whatever you get. Okay, if you are too confused, just take the point end point as the point of reversal of moment. Okay, and if the examiner asks you what is the source, you can tell that it's Elkington, because it is written in Elkington that you can either take glow or end point as the point of reversal of movement. Okay. Mm. Yeah, let's solve this. Okay, so the first step would be to directly convert this to a prescription before correcting for cycloplegia and the distance. Okay, so let's do it. Now, since both are of the same power, I'll take the smaller one. Okay, so I'll take 2.5D sphere. Okay, so once I've written here, I have removed plus 2.5 from all the meridia. So, okay, it is basically minus of plus 2.5D. So this becomes 0. Okay, now when I remove 2.5D from here, only plus 1D remains, right? Okay, so plus 1 diopter cylinder at, if it is acting in this meridian, the axis of the cylinder is perpendicular to it. Okay, so this is 180, then I'll write 90 here. Done. Shall we do the same thing for the left eye? Plus 3 diopter sphere with, okay, I'm gonna write here, plus 1 diopter cylinder at 90 degree. Simple. Now, the next step would be correction for cycloplegia. Okay, I'm gonna write cyclopentalate itself. And distance. Okay. For cyclopent, it is 0.75 diopters. For hometropin, it's 0.5. For atropine, it is 1. Okay. Yeah, for distance of 2/3 meters, basically you need to take the reciprocal. So reciprocal of 2/3 is 3/2, which is basically 1.5 diopters. So total deduction oh dear Lord, there is no space. Okay, total deduction from sphere. Okay, you are not deducting anything from cylinder, from sphere only. It's 2.25. Okay, so now let's apply this to the sphere there, so we have the final answer. Okay, it's going to be 0.25 plus, yeah, please don't forget the signs. Okay, they're very important. The cylinder is going to remain the same. Okay, it's not going to change at all. You're going to write the same thing. This is right eye. OD. OD is oculus dexter. OS is oculus sinister. Okay. Yeah, 2.25 needs to be removed. So that will be 0.75 d plus 1 and 90 degree. Okay, so as you observe, the deduction is only from the sphere. That is why don't try to deduct all this from the cross cylinder. Sorry, from the refraction cross. If you try to deduct all of that from the refraction cross, you're going to create a lot of confusion. So that is why convert the cross to a prescription. Then do the correction for distance and cycloplegia. Okay. And then the correction is always only from the sphere. That is super important to remember. Don't deduct it from everywhere. It's only from the sphere. Okay. So now, this is not the end of it. The end of a refraction case is the diagnosis. Right. Now, how will you write the diagnosis? So basically, this is a compound hypermetropic astigmatism with the rule. Okay, it's a pretty simple example, but this is something a lot of people get confused with. So we'll have a discussion after this one. Here with examples, I'll teach you a little bit more about how to how to make this diagnostic sentence of simple or compound hyperopic myopic astigmatism with or against the rule. It is very, very simple. There's hardly anything in it, but yet I'll just anyway, I've explained so much, so I thought I'll finish the whole thing. Okay. The next important thing is spherical equivalent. This is something a few examiners like to ask. That is, see, the concept is only this much. That is, the sphere is acting in all meridia. The sphere is acting in all meridia, whereas the cylinder is acting only in one. Basically, the perpendicular one, perpendicular to its axis. So, the sphere's power is full, whereas the cylinder's power is half. So the spherical equivalent is full spherical power plus half cylinder. So in this case, the spherical equivalent for the right eye will be 0.25 d plus half of 1 diopter of the cylinder. Okay, actually the plus is here. Now it's right. Okay, so that is going to give you a plus 0.25 d plus 0.5 d. The spherical equivalent of this prescription is 0.75 d. That's it. Full sphere, half cylinder. The reason why I am keeping the signs is because when there is a minus sign, then the addition will result in minus. So let's okay, I better give an example rather than making correction here. It will simply create a lot of confusion or else. So basically the concept is full power of the sphere plus half of cylinder. Okay, that's it. Transposition is very, very easy. There is a section in Elkington that can make you understand that in like probably 5 minutes. It's very, very simple. There's hardly anything. Sum sine axis. Okay, I'll use the same example. Let me just write the same thing down here. 0.25 d plus 1 dc at 90 degree. So you get the sphere by the sum. That is, you will add these two. So it becomes 1.25 d. Okay, done. we got the sphere. For the cylinder, you're just going to change the sign. So plus, I'll make it minus 1.00 DC. Axis, make it perpendicular at 180 degree. That's it. Take the sum of both to get the sphere. Change the sign for the cylinder. Perpendicular axis. That's it. That is transposition. Okay. This is transposition of a cylindrical lens. A cylindrical lens is different from a toric surface. Okay. Because a toric surface at the end of the day is a cylinder that has been bent along its axis. Okay, it's a little complicated thing. Let's leave that. Now, as I said earlier, I'll explain on how to arrive at this provisional diagnosis. I told you guys that this is a compound hyperopic astigmatism, which is with the rule. It's very simple. We'll do it with examples and you guys will understand in no time. Okay. Before that, I think let's do a bit of a conceptual thing. Yeah. See, in the figure A, parallel rays of light are coming to a focus on the retina with accommodation at rest. So that is the state of emetropia. If they're coming to a focus in front of the retina, then it becomes simple myopia. If behind the retina, then simple hyperopia. This is conceptually easy, nothing much. Now, when the two principal meridia are focusing them in two different planes, and one is at the retina and another in front of the retina, then it becomes simple myopic astigmatism. When one is behind the retina and another on the retina, it becomes simple hyperopic astigmatism. Okay, even this is somewhat simple, right? Conceptually to understand, nothing much. Now, when both the principal meridia are focused in front of the retina but at two different planes, then it is compound myopic astigmatism. Same goes with compound hyperopic astigmatism. That is, they're focused behind the retina but two different planes. Okay. If one is in front of the retina and another behind, then it is mixed astigmatism. That's it. Let's now try with examples, because you're going to get a prescription and you need to, correlate that and do this. But that correlation takes a long time to, do and, arrive at. So there is actually a simple trick to follow. Now, if there is no cylinder in the prescription, only sphere, then there is no astigmatism. Look at the sign of the sphere. If it is minus, then it is just simple myopia. If it is plus, then it is just simple hyperopia. Okay. If there is cylinder, only then astigmatism is coming into play. Okay. Now, I have only described astigmatism because that simple spherical thing is obviously very basic and I'm sure all of you guys know. So, yeah, let's go to the first example, this one. Here, there is no sphere. This sign indicates the spherical power is 0. Okay, and there is a cylinder of minus 2. Okay, at 180 degree. When the sphere is 0, only the cylinder is acting. That too in one meridia. The other meridia, it is focusing on the retina. That's what it means. So, when the sphere is 0, it is simple. Look at the sign of the cylinder. It is minus. Myopic. Astigmatism. Easy, right? Okay, let's move on to the next one. Second one, no sphere, only cylinder, simple, plus sign, hyperopic or hypermetropic, same thing, astigmatism. Okay, then comes third and fourth. Now third and fourth are different from 1 and 2. Why? There is a sphere. Okay, once there is a power in both sphere and cylindrical column, you will look at the sign. They are of the same sign, right? Okay, so it is compound. Okay, before this I need to tell you guys a little bit something else. That is, see, when they are having the same sign, that means the refractive error is in such a way that both are either in front or behind. In case of this plus thing, both are behind the retina. In case of this minus thing, both are in front of the retina. The only confusion comes when the sphere and the cylinder are having different signs. Can you see here? Yeah. So when this happens, you need to look at which is bigger. Okay, because this can either be simple or compound astigmatism or a mixed astigmatism also. Okay, so this one will require a bit of intensive thinking. Before that, let's do the easy ones. Okay, so as I said, both meridia are in the same direction, but nothing is on the retina. So this is compound plus hyperopic astigmatism. Again, there is a sphere as well as a cylinder and they are of the same sign. So this is compound, myopic, astigmatism. Okay, let's move on to the end of the discussion and the only complicated thing. Okay, so here, as I said, there is both sphere and cylinder, but they are not of the same sign. So when they are not of the same sign, you need to actually see the value. Okay, you'll have to see the value of the sphere and the value of the cylinder. It is the same value. Here, sphere is bigger, cylinder is smaller. Here, the sphere is smaller, the cylinder is bigger. Each of these are going to have different results. Okay. When the sphere is equal to the cylinder, that is same, means simple. So simple. Now myopic or hyperopic, always look at the sphere. When the signs are different, you look at the sphere. You see if the sphere is same as the cylinder. You see if, what is the sign of the sphere. It is plus. So this is actually a hyperopic astigmatism. This seems a little confusing, right? But the thing is, +2 is acting in all meridia, whereas -2 is neutralizing it in one meridia. So it becomes 0 in that meridia. So there will be only +2D remaining in one of the meridia. That is basically the one that is perpendicular to -2. I'll explain that again. See, when you give a sphere of +2D, +2 is acting in all the meridia. Now, -2 diopters at 90 degree. that will act in the 180 degree. So it's going to remove that plus 2 and it will become 0 in this meridian, whereas only plus 2 will remain in this meridian. And that is why it is actually a simple hyperopic astigmatism. So you don't have to use your brain so much during exam. See if there is a sphere and a cylinder. See if they are having the same sign. If they're having the same sign, it's easy. It's a compound myopic or hyperopic astigmatism. If they are not of the same sign, see the value of the sphere. Compare it with the cylinder. If it is same, then simple hyperopic astigmatism. Hyperopia or myopia, you will check with the symbol or the sign of the sphere. Okay. Now the next example is showing us a higher sphere. Okay, so there is a trick to remember this. Here the sphere is the chief or the commander because it is of larger value. It's larger, so it is chief or it is a commander, whatever helps you remember. So you will write compound. Now you will look at the sign of the sphere. So again, this is hyperopic astigmatism. Okay. Now, this is the last example is the trickiest of them all. Here the sphere is smaller than the cylinder. When the sphere is smaller than the cylinder, that means one meridia is plus, the other one is negative. So this is actually mixed astigmatism. Okay. Same thing, you'll see if there's a sphere and a cylinder both given, same sign, no, not a same sign. It is plus and here it is minus, and so you will look at the value of the sphere. It is lesser. Once it is lesser, it is mixed. Okay, we have actually solved all types of problems. Now the only thing that you guys need to learn is to differentiate with the rule from against the rule astigmatism. This is very easy. A plus cylinder at 90 degree and a minus cylinder at 180 degree is considered to be with the rule. Okay, so plus 90 minus 180 is with the rule. Anything other than this combination is against the rule. That's it. There is also another way to remember it. Okay, a plus is like a perpendicular, or you can actually take a plus as a vertical line. Okay, and 90 degrees is again vertical, right? So both the lines are in the same direction, so it is with the rule. Minus is a horizontal line. 180 degree again is a horizontal angle, as you can see here I've drawn. Okay, so again the lines are in the same direction with the rule. In against the rule, see, minus, but 90 degree is a vertical line. They're not in the same direction, against the rule. Plus, but plus, okay, plus is taken as a vertical line and 180 as a horizontal line. They're not in the same direction and therefore against the rule. Okay, we are done with everything. So the provisional diagnosis you will write as simple hypermetropic astigmatism with the rule or whatever. This is the complete diagnosis for a refraction case, and you know how to get the spherical equivalent as I explained. And transposition again is very easy. Sum, sign, axis. That's it. And I've explained this already. Yes, that's it. Thank you guys.